Hi, my name is Emma Hoggard, and this is for the Lab 2 Sweet Density. And my hypothesis is I imagine that when the candy bars are fully intact, the Snickers will have more density than the Milky Way. However, when they are cut in half, the Snickers will still have more density than each half, but less since it's cut in half. So first off, I'm going to measure these. This is the Milky Way. This is a Snickers. The Snickers is 9 centimeters in length. Two and a half centimeters in width, and 1 centimeter in height. The Milky Way is also 9 centimeters in length, two and a half centimeters in width, and 1 centimeter in height. Wow. Actually, I think it's 1.5. The Milky Way. The mass, according to the Milky Way wrapper, is 52.2 grams, and looking on my scale as well, that equals. And for the Snickers, it is 52.7 grams, and that equals as well. So in order to find the volume of these candy bars, you go length times width. So for the Milky Way, I'm going to go 9 times 2.5. And for the Snickers, I'm also going to go 9 times 2.5. And so, get my calculator. Nine times 2.5 equals 22.5 is the volume. So the next step is to find the density, and density equals mass divided by volume. And so we found our volume mass in the previous problem. So I took for the Milky Way 52.2 divided by 22.5, and for the Snickers I took 52.2 divided by 52.7. I'm sorry, divided by 22.5, and for Milky Way I got 52.2 divided by 2.5. 2.32 would be the density, and for the Snickers I got 52.7 divided by 22.5, which equals 2.34. So the next thing to do is to cut the Snickers and Milky Way in half. So as you can see, I've cut them in half. So now we have to measure them. We'll start with the Snickers first. This is about 5 centimeters. I guess that's not perfectly even. And then the other one is 4 centimeters. Snickers. And Milky Way, 5 centimeters. And then centimeters. So the width of these, three centimeters. Three centimeters as well. For the Milky Way, for the Snickers, 3 centimeters. And for the other half, it is 3 centimeters as well. For the height, the height is practically 2. 2. Two and 2. So to find volume, like we earlier discussed, it is length times width. So length times width, and length times width. So we're gonna go 4 times 3, and then 5 times 3, and then once again 5 times 3 and 4 times 3. And so that would equal 12. And 5 times 3 equals 15. So in order to find the mass, we simply just cut the Snicker bars in half. So we're just going to divide the mass of the full candy bar in half. So it would be, the mass would be 52.2 divided by 2 for the Milky Way. And for the Snickers, it would be 52.7 divided by 2. So you would go 2.2 divided by 2 is 26.1. 26.1. And then for the Snickers, it's 50.7 divided by 2, which equals 26.4. 26.4. And so to find our density, it's density equals mass divided by volume. So you would go 26.1 divided by 12, and then 26.1 divided by 15 for the Milky Way. So I'm going to go 26.1 divided by 12 equals 2.16, and then 26.1 divided by 15 equals 1.74 for Milky Way. And then for the Snickers, I'm going to go 26.4 divided by 15 and 26.4 divided by 12. So 26.4 divided by 15 equals 1.76. And then 26.4 divided by 12 equals 2.2. And lastly, to find the average of each of the candy bars, you would simply take your full candy bar density, which is 2.32 for the Milky Way, and you would add your split up ones. So I got 2.16 and 1.74. So add those and you get 3.9 plus 2.32 divided by 2, and you get 3.11. Which is the average density for the Milky Way. Same with the Snickers. The whole Snickers density is 2.34. Split in half, one is 1.76, one is 2.2. So I did 1.76 plus 2.2, which equals 3.96, plus 2.34 divided by 2, and I got 3.15. So overall, my hypothesis was correct, and the Snickers is more dense than the Milky Way.